previously we had an introduction to compound and multi-step probability. This is where I showed you how to find how many total outcomes there are and how to find the sample space using a list, a tree diagram, or a table. Today we're actually going to get into the actual probability. Most often we're going to represent our probability as a fraction, but you may also represent it as a decimal or a percent. Now, in order to do this, you need to remember that simple probability is the number desired over the total number. And that's important because we're going to be using simple probability for multiple events because we're now in multi-step probability, and we will actually be multiplying, kind of like what I said in the last video about, I'm going to call it multi-step probability because we are multiplying. So compound events, multi-step events, they're the same. Happens when we have and probability, meaning in this case, I'm going to spin the spinner and I'm going to roll a number cube. Now you're going to see dice, just normal dice that you're used to with numbers 1 through 6 on it, called a standard number cube, and it's the same thing as normal dice. So in this example, we have to talk about some notation. P is representing probability, and inside the parentheses is what you're finding the probability of, and the comma kind of means and then. So for this one, we're finding the probability of blue and then a 6. The thing first inside the parentheses is your first event and then your second event. So here our first event is the spinner, and then the second event is the rolling a number cube. So we're going to find simple probability of each events and then multiply them together. So the probability of getting a blue in the spinner, well, there's only one blue section out of 5 total sections, so the probability is 1 out of 5. And the probability of rolling a 6, well, there's only 1 6 on a standard number cube out of 6, and so it's 1 out of 6. And because we have multiple events, we're multiplying. When you multiply fractions, you just multiply straight across the numerators and straight across the denominators. So 1 times 1 is 1, and 5 times 6 is 30. Done. That's your probability. Most often, I'm going to want it in fraction form, but you may convert it into a decimal or percent if you're asked to do so otherwise. Next, probability of an orange and then an odd number. So there's only 1 orange out of 5 total sections on the spinner, so that's our first event. We are going to be multiplying. Now, odd. On a number cube, we have 1, 2, 3, 4, 5, 6. 1, 3, and 5 are odd numbers, so we have 3 out of 6 that are odd. Now, I don't actually want to leave it as 3 out of 6. I know you can do the math for it, and you're going to get the same answer if you don't simplify it. But there might be a time when the numbers get to be pretty big, and you want to just simplify along the way. 3 out of 6 is the same thing as 1/2, because 3 goes into 3 1 time, and 3 goes into 6 2 times. So now you have smaller numbers, and it's just a little bit easier to do your math with. We're going to multiply the fractions. So 1 times 1 is 1. 5 times 2 is 10. 1 out of 10 chance that you're going to spin an orange and get an odd number between the spinner and the cube. Okay, what's the probability of not getting a green? I added this on here because you are going to see questions that aren't asking for what it wants, it's asking for what it doesn't want. So if it doesn't want you to get a green, that means you could have orange, pink, blue, red. There's 4 other things that you could get. You just don't want a green. So 4 out of 5 is desired. And probability of getting a 3 on a number cube, well, there's 1 3 out of 6 total options, so 1 out of 6. There's nothing we can simplify here, so we're going to go straight to multiplying. 4 times 1 is 4. 5 times 6 is 30. We can simplify at this point. Now, I do want you to always simplify your answers. I may not be taking off points if you don't simplify just yet, but when you get to high school, you will get points taken off. So it's best to practice now. What goes into 4 and 30? 2 goes into 4 and 30. 2 goes into 4 2 times and into 30 15 times. So our final answer is 2 out of 15. One more is find the probability of spinning a primary color and greater than 2. Now, you will see some of these problems pop up because it's assessing you on two things. Do you know your primary colors? And can you read these symbols? Primary colors are yellow, blue, and red. We don't have a yellow here, but we do have a blue and a red. So we have 2 sections out of 5 that represent our primary colors here. So 2 out of 5. Times, our next event is greater than 2. Now you do need to know the symbol does not mean greater than or equal to. So we're not counting 2. It doesn't have a line underneath. If it had a line underneath, you'd count the 2, but we want greater than 2. So that means we're going to count 3, 4, 5, 6. So there are 4 numbers on the number cube that are greater than 2, 4 of them out of 6. Oh, hey, I see a fraction I could simplify. Let's make the numbers a little bit more simplified so the math is not going to have as large of numbers. What goes into 4 and 6? 2. 2 goes into 4 2 times, 2 goes into 6 3. Multiply straight across. 2 times 2 is 4. 5 times 3 is 15. And that is your final answer. Okay. Next, we have a bag with some marbles in it. And we're going to talk about with replacement and without replacement. Now, the scenario you'll get will have more words and it'll set it up a little bit more detailed, but I just wanted to give you the gist of what replacement means. So here, we want to find the probability of pulling a blue marble, replacing the marble, and then pulling a red marble. So first, we want to pull a blue marble. We have 5 blue marbles out of a total of 10. So our probability is 5 out of 10. We'll simplify that in a moment. But then we're going to replace that blue marble back into the bag. So that means there's still going to be 10 marbles in here. We are going to use multiplication because there's multiple events. There's still going to be 10 marbles. And now we want to pull a red. How many red marbles are there? 3. We can simplify this 5 out of 10. 5 goes into 5 one time and 10 2 times. Now we're going to multiply straight across. 1 times 3 is 3. 2 times 10 is 20. So there's a 3 out of 20 chance that that might happen. That looks like a 0, but that's supposed to be O for orange. Now we want to find the probability of pulling an orange twice, but in between you replace that orange. So we're going to pull out an orange. We've got 2 orange out of 10. We are going to multiply. We are going to assume that we're replacing the orange marble. So there are still 2 orange marbles in the bag out of 10 total. Let's do some simplifying so that we don't get too big of numbers. 2 goes into 2 one time. 2 goes into 10 5 times. This is actually the same fraction, so it also simplifies to 1 out of 5. 1 times 1 is 1. 5 times 5 is 25. And there's a 1 out of 25 and 1 out of 25 chance of pulling an orange twice when you replace it in between. Okay, so let's talk about without replacement. You might have picked up on what to do at this point, but we're still going to go through it. What's the probability of getting a blue? It's going to be the same thing as before. There's no event affecting that. There are 5 blues out of a total of 10 total marbles. Now this time we're going to assume success. So we're going to assume we did actually get a blue marble and we're not going to replace it. So that means this blue marble gets taken out of the bag. So now how many marbles are there? There are 9. We're still multiplying. And we want to find the probability of getting a red. So there are 3 reds in here. So that's really the only difference is we're taking 1 away from the total. We want to simplify these fractions to make the math a little easier. 5/10 simplifies to 1/2. 3 goes into 3 one time and into 9 3 times. So that simplifies to 1/3. 1 times 1 is 1. 2 times 3 is 6. There's a 1 in 6 chance that that will happen. Let me put this blue marble back in the bag because we're doing a new problem. We want to find the probability of pulling an orange, of you not replacing that orange marble, and then you want to pull another orange marble. So what's the probability of getting an orange? It should be the same thing as before because it's our first event, so there's 2 out of 10 times. Now we're not replacing it, so we're going to take that orange marble out. How many total marbles are there? There's 9 now. And only 1 orange marble left because we're going to assume success the first time. Now this one's different from the previous one because the previous one, red, when we pulled out that blue, it didn't affect how many red were there. Now in this case, we're pulling out 1 orange, and so not only are we subtracting 1 away from the total, but because we pulled that orange out, we also have to subtract away 1 away from how many oranges there are too. 2 out of 10 simplifies to 1/5. Multiply straight across. 1 times 1 is 1. 5 times 9 is 45. And that is your answer. There are going to be an infinite amount of different types of compound events that you may come across. So please feel free to reach out to me if you have any questions because they all kind of look a little different. It's going to be the same step every single time.